Hello, grade 11 A-level students. Right now I'm going to explain about the last part of the carboxylic acid and derivative chapter. The last is about the relative reactivity of acyl chlorides, chloroalkanes, and chloroarenes. Acyl chloride is the derivative of carboxylic acid, and then chloroalkanes is a part of halogenoalkanes, and chloroarenes is the chlorobenzene. As we saw in previous section, chlorobenzene does not undergo hydrolysis with water even with concentrated sodium hydroxide solution because of the overlap of pi bonding system. While acyl chloride, in the other hand, react much more readily because it is more reactive due to the electronegative element, and chloroalkanes less uh, react less than acyl chloride with water or hydroxide. So there are two reasons for this. First, here the addition elimination therefore has lower activation energy than the straight uh, nucleophilic substitution 2 or SN2 reaction. So the unsaturated nature of the C double bond O allows that COH bond to be formed before CCl bond has broken. And then we know that when acyl chloride reacts with water, it will form carboxylic acid. And then in the middle of the carboxylic, in the middle of the process, so this this C double bond O reacts with the oxygen that make this bond. And then in order to achieve stability, this electron from the C being taken by the Cl that makes the Cl become nucleophile. Nucleophile meets with the hydrogen electrophile and then become HCl as the side product. So the main product is carboxylic acid. Okay, and then the second reaction, the carbon atom in acyl chloride is attached to two electronegative atom, which is oxygen and chlorine. So is polarized to dipole positive to a greater extent than the carbon in chloroalkanes. In chloroalkanes, there is only one electronegative atom. This one, the effect of the presence of two electronegative atoms, this allows to attract nucleophiles more strongly. We know nucleophile is a molecule that has excess of lone pair. And then now the last part is polyester. Polyester is the formation of polyesters, many esters. Polyester can be formed from two. As we know, when we studied about the AS level, we know that polyester formed from the alcohol and also carboxylic acid that makes an ester linkage. But this one is using acyl chloride. Acyl chloride is much more reactive than carboxylic acid. So in this process, it does not require any stronger catalyst. But in carboxylic acid and alcohol, it requires strong catalyst, which is concentrated sulfuric acid and presence of heat. The product is the same ester linkage. The process is called as condensation polymerization. Okay, and then there are many applications of the condensation polymerization. Some product are like this one for the yacht, and also for the fabrics contain polyester, and then also for our fabrics that we are using. In any fabrics, there's always written tag. This one is 100% polyester, or how many percent polyester, and nylon and cotton. Okay, this is the end of the chapter 27. 6, which is carboxylic acid and derivative.